talk a bit about some issues that will come up on your test. So this is a problem. You've seen problems like this on the MyMathLab, but there's some nuances that I want to make sure you get when filling them out by hand on pencil and paper. So the first question is, we got this function, and it's just graphed here. Here's f of x. And we might be asked, what is the local max for this function? When you're asked the question, what about this, that means we are looking for a value of, y. It's the largest value of the output within a given neighborhood. So the value y equals 3 is the output at this top of the hill point that we know is a local maximum. When we are asked where is the local maximum, where is asking for a value of x. So what is the value of x when this function reaches this local maximum? Well, the value of x, the input, is -2. And so that's where the local max is. This is what the local max is. Now let's try the same things with the absolute minimum. All right, so the absolute minimum, you probably already know, this is right about here. Absolute minimum is right down here. And so then what is it? What is the absolute? Well, the value of y at that place is 0. Where is it located? That's being asked about what value of x. And it occurs at x equals -4. So that is kind of picking apart that question, what versus the question, where. Okay? Now we're asked also, where is the function increasing? Oopsie, misspelled where. Now we've got it right. Where is the function increasing? Well, again, you can picture it's along this interval right here. But again, when we're asked about where, we're looking not for this set of points from -4, 0 to -2, 3. We're asked for an interval, a set of values of x. And so let me just kind of use the lavender to discover. We're trying to describe this set of values of x where the function is increasing above those values of x. And so where that occurs is on the interval from -4 all the way up to -2. So those are, it starts at x equals -4, ends at x equals -2. We're going to use open intervals on those, okay, for those describing the domain here. It's a little bit trickier with the -4 because mathematically speaking, some would say the function is actually increasing at -4. But I see a discontinuity there, and that's not going to be increasing. At -2, it's definitely not increasing. It's neither increasing nor decreasing. It is level there. All right. So the next thing we're asked is, what are the domain and range? And so domain, whenever you're looking for domain, that means possible x values, possible inputs. And so we look, what are the possible inputs? Well, they're everything pretty much between -4 and +1. Do they include -4? Well, yes, since -4, 0 is on the graph of the function. So you've got to put a square brace at -4 to denote that -4, x equals -4 is part of the graph. So is x equals +1. So it gets a square brace as well. So the domain of this function is -4 to 1, the closed interval, the one with braces on the end. What the range of this function is where the lowest value of y is 0. The highest value of y is 3. Range is possible y values. Okay. Again, is y equals 0 included? Yes, it is on the point -4, 0. How about y equals 3? Yes, it is on the point 2, 3. So just to be careful, you want to distinguish between what and where for local max and absolute max, local mins and absolute mins. Realize, of course, that local mins are these mountaintops here. They may not be the absolutely highest or lowest value in the function, but they're a place where, hey, in the neighborhood, it's the highest point around. Absolute maxes and mins are basically the highest or lowest value you see in the function. Sometimes one of these local mins can also be a local max can also be an absolute max. That's in fact the case here. But this absolute max here or absolute min here isn't a local min because there's no neighborhood around. There's no mountaintop or valley. So it's just an absolute minimum. And where it is at x equals -4. What it is at x equals 0. Okay? Describing where a function is increasing, we're looking for values of x on which the function is increasing or decreasing. And finally, domain and range, we're looking essentially again for intervals describing the set of possible x or y values. Hope this helps.